up, guys? Welcome back. Welcome back to class. How you doing? I'm Mr. Herb, and I'm here to show you a little bit of math, man. You got 5 minutes? Good. Let me teach you some math real quick. Today's lesson is another geometry lesson, man. I love geometry because I get to draw pictures. But let's get to it, man. Here we go. Oh, yeah. Pyramids and cones. You got it. Let's get to it, man. Give me the pyramid up here. Oh, yeah. Oh, yeah. Pyramid look good, don't it? Of course it does. Anyway, let's get to it. So, first off, a couple of things that I think we all need to understand about pyramids. Pyramids only have one base. And so the faces of this pyramid will all meet at one point at the top. Usually called the apex. Anyway, the first thing that I think we should talk about with pyramids is what they look like from different views, right? Every pyramid, no matter what the shape of the base of the pyramid is, every pyramid, when you look at it from the side, looks like this. Yeah, a triangle, of course. And as you can see, you know what? Let me highlight a couple of things here. Maybe it'll make it easier to understand. So, these lateral edges down the side of the pyramid will be the same as these lateral edges down the side of the pyramid. Good. That's exactly what that's called, to a lateral edge. And I need you to understand that that is different from this. Yeah, that. See that length of that line going down the middle of the face? That's a different length than these two lateral edges. So if this lateral edge is 10, this is not 10. Let's get that straight. Now, second thing, when it comes to pyramids and cones actually, one shape you'll always see in pyramids. You've probably seen it already. Right triangles, and of course, you know what comes along with right triangles. Oh yeah, Pythagorean theorem. Of course, wherever right triangles go, Pythagorean theorem is sure to follow. So, remember this, when solving problems, right triangles always come up. On the faces of the pyramid, inside the pyramid, inside the pyramid. This red triangle inside that pyramid, it's a right triangle. This blue triangle inside that pyramid, it's a right triangle too. So you're going to be using a lot of Pythagorean theorem inside of pyramids, right? One more thing I need you to understand. The height of a pyramid is not the lateral edge. It's not the little red line coming down the face. The height of the pyramid is inside. That's the height of the pyramid. And that height is different from this lateral edge and different from this length down the face. Yeah. Now, of course, just like a prism, to name a pyramid, you name it by the shape of the base. This base looks like a rectangle, so you know what this pyramid is called? A rectangular pyramid, exactly right. That's what it looks like when you look at it from the top. Whenever you look at a pyramid from the side, it's a triangle. Whenever you look at a pyramid from the top, it's the shape of the base. Yeah, exactly right. So you can have square pyramids. You can have hexagonal pyramids. Could you have a circular pyramid? What would that look like? Ha! All right. So a cone is just like a pyramid. It has a height, and it also has a slant height. Yeah. So there are two heights to a cone. There's the vertical height that comes straight out the middle of the base, the middle of that circle. That's the vertical height. That's H. And you have what's called the slant height, L. You see anything inside that cone that looks familiar from inside the pyramid, maybe? Oh yeah, it looks like another one of those right triangles. A right triangle we can use Pythagorean theorem for? Oh yeah, oh yeah. Ooh, volume. Let's go back to that pyramid real quick. Bang, yeah, that pyramid. Volume formula looks like this. So just understand, you may see it either way, but multiplying something by 1/3 is exactly the same as dividing that by 3. Remember, capital B, the area of the base, exactly right. This base is a square or a rectangle. You have to find the area of that base to put in for capital B. Yeah, H is equally as important because this H is the vertical height. When I say vertical height, I mean this. Yeah, that line going up the middle. Now you won't always be given that. Sometimes you'll be given this lateral edge, and sometimes you'll just get this line down the face. That's when you use your right triangles. Yeah, because that height is going to be involved in one of those right triangles inside. Just make sure this H is this H. Exactly right. You think it's really different for cones? Let's see. Bang. All right, here's my cone. So if this is a circular pyramid or whatever, and the area, the base, B is the area of the base, which shape is this base? Isn't that base a circle? How do you find the area of a circle? I know. Yeah. B is just a circle. The area of a circle is pi r squared. I can just throw that right in there. That's how you find the volume of a cone. Yeah, exactly right. So now don't get it confused. Notice the slant height L didn't pop up anywhere in there, right? We're going to use that for other stuff later, and you might have to use that to find the actual vertical height. But don't forget, got to be the vertical height. All right, I hope this helps, man. I got some practice problems coming. Make sure you check them out. Thanks, guys. I'll see you next time.